Supplemental math videos from Circle Christian School. The imaginary all-seeing eye. Oh, what to do when faced with the negative square root? Well, you eye it, of course. Engineers use it on things like stresses for beams or studying Renaissance. Basically, anything that has such a fluctuation to it that there is not really a good consistency, but in the chaos, there actually is, and we call it I. So mathematicians many years ago were faced with the fact that they had a square root of -1, and they had to come up with something to deal with it. There was a little bit of pushback here and there, but eventually they all came to terms to it. Just like 0 at the very start of all numbers, there was a pushback on 0, and then there was a pushback on negative numbers, and eventually we came up to this negative number under square root. We had to do something with it. What follows here is basically what happens when you start powering up the number I. So to simplify any I number to a power, we use multiples of 4. So beginning with the fact that I to the 4th power divided by 4 would give us no remainder, it gives us 1. And every remainder consequently follows the pattern that was given to us in the first slide. It goes I, -1, I. So depending on what the remainder is, once you've divided by 4, will dictate what you simplify down to. As long as you know what the remainder matches, or the first I to something powers here through 8, you can do pretty well. So I to the 12th would equal I3 with the remainder of 0, or 1. I to the 17th would be I4 with the remainder of 1, takes us to I. And I to the 255th has 63 with the remainder of 3, means it's a negative I. Imaginary numbers follow the rules of real numbers. AI is where A is a coefficient, is just purely imaginary. But when we have B plus AI, where B is a real number, it's an imaginary number or complex, which means now Descartes can be happy and throw it into his coordinate plane just by renaming that X is now real imaginary numbers. So given a complex equation, 5i would mean that the real number is 0 and the imaginary number is 5i. 6 minus 4i, our coordinates would be 6, -4i. And -8, a real number, the coordinates would be -8 and 0. I think you get the picture. Now, because we use the premise of the imaginary system is to follow the real number system, a lot of the real number rules apply to I. So we can add, subtract, multiply, and divide. We can use operations with I. It's just that you got to remember that the real number goes to the real number and the imaginary goes to the imaginary number. Nothing new here, just a longer license plate. Alright, so we're going to add the first two together. Let me get a fun color. Here we go. And I, again, am going to go real to real. So we have the 3 plus the 6 gives us a positive 9. And then we have the 2i plus a -4i, means we have -2 and an I. That wasn't a pretty color. Same thing happens with subtraction. What you have to remember is that it's not plus, and that this negative is really changing the signs of everybody else. So our first part with the real numbers, we have a -8 minus a -2, which gives us a -6. Fun integer stuff. Just be careful there. And 1i take away a 3i would give us a -2i. Multiplying is going to play the same game here. You know, again, it's going to be real number to real number, imaginary to imaginary number. So we're just going to distribute the 2 in the first multiplication here to everybody. It gives us 8 plus 12i. And on the next one, of course, what we're going to do is just do the FOILing thing. Although there is kind of a neat little caveat that happens here, and it's any time that you're going imaginary to imaginary. So 2 times the 4 is going to give us 8, and 2 times a negative 2i would give us a negative 4i. And now we're going to distribute the I, and I times 4 is a positive 4i, and I times a negative 2i gives us a negative 2 and an I squared. Alright, now we have to do our combining like terms things. So we have an 8. Surprisingly, the 4's kind of cancel out. Doesn't always happen this way, it just happens to be one that worked this way. And then lastly, we have a negative 2 and an I squared. What you have to remember here is that I squared has a very special value to it, and that is negative 1. So what we actually have is 8 minus the 2 times a negative 1, which means it's actually 8 plus 2, and we get a 10. I squared is the number that the mathematicians were looking for. What do we do with a square root negative 1 in such a way that we can bring it back to our real number system? Well, if we square it, we end up with a number from the real number system. Dividing or rationalizing the denominator with our I numbers is a lot of what happens with when we have a radical. We have to do that difference of 2 square things. So remember, it's always the first guy squared, which would be a 4, and then the last guy squared, which would be a 3 and an I squared, and a minus sign in between, which would yield for us a 4 minus a 3 times negative 1, or 4 plus 3 equals 7. Try another one. We would get 1 squared, I squared, which is a negative 1, minus sign in between gives us 2. Alright, so to do the division, what we're going to have to do is rationalize the denominator here by using the conjugate. Remember, a conjugate is a binomial that allows us to be the difference of 2 squares. So this is going to be 5 plus I. And up here we're going to go 5 plus I, because whatever we multiply to the denominator, we have to multiply to the numerator. Alright, difference of 2 square things. So we're going to have 25, an I squared, and a minus, remembering that this is a negative 1, so it gives us a 26. And then we just have to distribute the other guy. Gives us 15 plus 3i. And that's all there is to being rather imaginary. You're there and you're not.